Hello all my dear students. Today we are going to discuss a very important topic in physics which is related with all the things around us. The name of the topic is motion, which we have to study in class 9th. Dear students, all the things which we see around us, these all things are in two states. Either these things are in rest or in motion. As you can see here that the earth is in motion, the car is in motion, the butterfly that is also in motion, but the tree which is there, it is at rest. Today in this chapter, we will cover these topics as mentioned here. The first one is terms related to motion. Second, distance and displacement. Third, speed and velocity. Fourth, acceleration and deceleration. Fifth, equations of motion. Sixth, graphical representation. And we will also cover some numericals. But in this video, we will cover till speed. So first we talk about rest. As we know the definition of rest, a body is said to be in a state of rest when its position does not change with respect to a reference point. For example, as you can see here that the tree and the house is there, and these two things are at the same position with respect to each other. Even after 5 hours or 5 days or 5 years, if we observe it, these things will be at the same position. It means that their position does not change with respect to time. So these things are at rest. Since we have discussed a word reference point, so here we see the definition of it. It is used to describe the location of an object. An object can be referred through many reference points. For example, let's say that, as you can see here that the bus stand is there and a car is moving on the road. So bus stand can be taken as a reference point. Now the reference point which we are taking for the motion of this car, that reference point is called origin. So here the motion of the car can be defined as by taking the bus stand as a origin. Next we talk about motion, which is very important topic, and as per the definition of motion we know that a body is said to be in a state of motion when its position changes continuously with reference to a point. For example, here tree is a reference point and the position of the car changes from point A to point B. So car is in motion. Now motion can be of different types depending upon the type of path by which the object is going through. It can be circulatory motion or circular motion. In a circular path, as you can see here that the earth has a circular motion. Linear motion, it in a straight line path. As we can see here that the car is in a straight path, moving in a straight path, so we can say that the motion of the car is a linear motion. Now we have a pendulum here. The motion of this pendulum can be considered as an oscillatory motion. Now we move further, and before we go and start the topic distance or displacement or speed or velocity, first we try to understand these two terms, which is very important. The first one is scalar quantity and the second one is vector quantity. As per the definition of scalar quantity, we know that it is the physical quantity having own magnitude but no direction. Example, distance, speed, etc. It means that in a scalar quantity we do not consider the direction. We only talk about numbers or magnitude. For example, the car covers a distance of 10 meter, but we are not mentioning any direction of this car. So this distance will be taken as a scalar quantity. Vector quantity, the definition is it is a physical quantity that requires both magnitude and direction. For example, displacement, velocity, etc. As we can see here that the car moves in a particular direction, that is east direction. So when the car is moving with a speed, let's say that 50 km per hour and in a particular direction, then we say that this speed is a vector quantity. So this speed will be called here as a velocity, because we are mentioning two things, the magnitude as well as direction. So velocity will be a vector quantity. Now we talk about distance and displacement. Distance, the length of path covered by a moving object in the given time, irrespective of direction, is called distance. Again, in distance we do not talk about the direction. We just talk about the path or the distance or the path covered by the object. We only talk about the numbers. We do not mention any direction here. So it is a scalar quantity. Its SI unit is meter. Displacement, the shortest distance measured from initial to the final position of an object, is known as the displacement. In displacement, what we do that we mention the direction as well with magnitude. So when we are mentioning the direction with the magnitude, so it will be a vector quantity. So displacement is a vector quantity. Now, since the displacement depends upon the direction, so the displacement can be positive, it can be negative or zero. Now try to understand it with the help of an example. As you can see here that the car starts from A to B and then goes to C and then goes to D. So the total path which is covered by the car from A to D, that is 5 meter plus 4 meter plus 3 meter, that is equal to 12 meter. It is called distance. But if we consider the shortest distance between these 2 points A and D, so the straight line between A and D will be the shortest distance in a particular direction. So the displacement will be the shortest distance between point A and D, which is 7 meter. So the displacement will always be smaller than the distance. It might be equal, but it will never ever greater than the distance. I believe you all are getting it. Now we discuss about the types of displacement. Since displacement depends upon the direction, so on the basis of direction of a moving object, we can say that the displacement can be positive and it can be negative. For example, if O is the origin here and a bike moves in the east direction while car moves in the west direction, so if we consider the displacement of the bike as a positive displacement, then the displacement of the car will be negative displacement, because these two things are moving in opposite direction. So that's why we are saying that the one is positive displacement, the another is negative displacement. Now we have zero displacement. Zero displacement means that if the final and the initial point or the position of an object is same, then the entire displacement will be zero. For example, as you can see here that the car moves from A to B and then B to C, then C to D, and finally it comes back to A. Since the initial point and the final point of the car is same, so we will say that the displacement of the car is zero here. Now we move further and we talk about uniform motion. As per the definition of uniform motion, when an object covers equal distances in equal intervals of time, it is said to be in uniform motion. For example, let's say that we have a car here which covers 5 km in 2 seconds. In another 2 seconds, again it covers 5 kilometers. In another 2 seconds, again it covers 5 kilometers. It means that in each and every 2 seconds, the distance which is covered by the car, that is just 5 kilometers. So we will say that the motion of the car is uniform motion. Now we talk about non-uniform motion. So non-uniform motion, it is quite clear from the term that non-uniform motion, it means that the motion of the object is not uniform. As you can see here that the car travels 5 km in first 2 seconds. In another 2 seconds it covers 10 kilometers. And in another 2 seconds it covers 15 kilometers. It means it is not certain that the car will cover the same distance in the same interval of time. So we say that the motion of the car is non-uniform motion. I believe you all are getting it right. Now we talk about speed and velocity. So first we see the definition. The distance traveled by an object in unit time is referred to as speed. It is represented as speed equals to distance upon time. Now, as we know that the SI unit of distance is meter and the SI unit of time is second. So the SI unit of speed will be meter per second. Since in speed we only talk about magnitude, we do not consider the direction of the object, so it is a scalar quantity. Now, speed can be categorized as uniform speed, non-uniform speed, or average speed. Uniform speed, when an object covers equal distances in equal intervals of time, it is said to be in uniform or constant speed. Non-uniform speed, when an object covers unequal distances in equal intervals of time, it is said to be in non-uniform or variable speed. So the uniform speed can be called as constant speed, while the non-uniform speed can be called as variable speed. Example for uniform speed and non-uniform speed is same as given for uniform and non-uniform motion. So that's why I'm not going to give you any example here. Now we talk about average speed. We all know that it is quite difficult to maintain the same speed on a road, right? So if we are not maintaining the same speed, it means that this motion will be a non-uniform motion. So the average speed of an object is obtained by dividing the total distance traveled by an object by the total time taken. Average speed equals to total distance traveled by total time taken. For example, if a car covers 5 km in 1 hour, 15 km in 2 hours, and 10 km in 3 hours, then average speed equals to total distance traveled. It means first we will add all the distance, 5 plus 15 plus 10 kilometers. That is equal to 30. Now divided by total time. So again we add all the time here. 1 hour plus 2 hour plus 3 hour, that is equal to 6. Now when we divide 30 by 6, we get 5. So 5 km per hour, that is the average speed of this car. So I believe you all have understood it clearly. Thank you very much for watching this video. You have a blessed day.